Have you ever looked at a map and wondered why certain animals live in one place but not another, even when the places are right next to each other? Well, there is an incredible invisible line in the ocean that explains one of the world's biggest wildlife mysteries. This line is called the Wallace Line. It runs through the islands of Indonesia, separating the wildlife of Asia from the wildlife of Australia. On one side, you find animals like tigers, rhinos, and monkeys, which are typical of Asia. But cross this imaginary line and suddenly you are in a world of completely different creatures, like kangaroos, cockatoos, and other marsupials that you would expect to see in Australia. It's a sharp, dramatic boundary that has puzzled scientists for a very long time. This amazing line is located in the Malay archipelago, threading its way between islands that look very close together. It passes between Bali and Lombok, and then runs north between Borneo and Sulawesi. To look at a map, you would think animals could easily swim, fly, or drift from one island to the next, but for millions of years, most of them simply haven't. The channel of water that marks the Wallace Line is incredibly deep, which is a big clue to its power as a barrier. Even when sea levels were much lower during past ice ages, this deep water trench remained flooded, creating a permanent water barrier that most land animals could never cross. It acts like a giant natural fence in the middle of the sea. The differences in plant life are just as stark and fascinating. On the Asian side of the line, the forests are filled with towering trees from the dipterocarp family, which are common throughout Southeast Asia. These lush tropical rainforests create a specific type of environment. But once you journey across the Wallace Line, the plant life begins to change. You start seeing more eucalyptus trees, the same kind you would find all over Australia. These trees are perfectly adapted to a drier climate and are a key part of the Australian landscape. This divide shows that the line isn't just about animals, it separates entire ecosystems that have evolved in isolation for an immense amount of time. So what makes this line so special? It's not a physical wall you can see or touch. It's a biogeographical boundary, which is a fancy way of saying it's a line that separates two completely different zones of life. Think of it like a meeting point of two worlds that have developed on their own separate paths. The animals and plants on the Asian side are part of the Indo-Malayan realm, while those on the Australian side belong to the Australasian realm. The Wallace Line is the precise point where these two great ancient worlds collide. It's one of the most abrupt and dramatic wildlife transitions found anywhere on planet Earth. And it all started with one man's incredible journey of discovery. The line gets its name from a brilliant British naturalist named Alfred Russel Wallace. Back in the mid-19th century, Wallace spent 8 years exploring the islands of the Malay archipelago, collecting thousands of specimens of birds, insects, and other animals. He was a true adventurer, braving dense jungles, rough seas, and tropical diseases to document the incredible biodiversity of the region. During his travels, he noticed something incredibly odd. As he sailed from the island of Bali to the neighboring island of Lombok, a journey of only about 35 kilometers, he saw a complete change in the animal life. It was as if he had traveled to a different continent in just a few hours. On Bali, Wallace found birds that were common to Asia, like woodpeckers and barbets. But on Lombok, those birds were gone. Instead, he found cockatoos and honey-eaters, birds that are characteristic of Australia. This sharp change fascinated him. He continued his travels, and the pattern held true. On the western islands like Borneo and Sumatra, he found monkeys, tigers, and rhinos, all classic Asian animals. But on the eastern islands like Sulawesi and New Guinea, he found marsupials like the cuscus, and an entirely different set of birds. He was the first person to scientifically describe this invisible barrier, and his findings were revolutionary for our understanding of how life is distributed around the globe. So, why can some animals cross the line while others can't? It really comes down to how they travel. Animals that can fly long distances, like some birds and bats, or those that can swim across open ocean, have been able to cross the deep water channel. Saltwater crocodiles, for example, are powerful swimmers and are found on both sides of the line. But for land-based mammals, reptiles, and amphibians, the deep-sea trench was an impossible obstacle. A monkey or a rhino simply can't swim that far, especially against strong ocean currents. That's why you don't find native monkeys in Australia or native kangaroos in Asia. They were trapped on their respective land masses for millions of years. The Wallace Line was a crucial piece of evidence for Wallace's work on the theory of evolution by natural selection. He actually developed his ideas at the same time as Charles Darwin, and his observations in this region were fundamental to his thinking. He realized that the distribution of species could only be explained by them evolving in isolation over vast geological timescales. The line showed that deep history, not just current climate or geography, shaped where animals live. His discovery of this invisible boundary remains one of the greatest contributions to biology and a testament to the power of careful observation in the wild. To understand why the Wallace Line exists, we have to travel back in time, millions and millions of years. The story begins with the slow, powerful movement of Earth's tectonic plates. Asia and Australia were once incredibly far apart and were part of different supercontinents. For eons, they drifted across the globe, carrying their own unique sets of animals and plants with them. The animals on the landmass that would become Asia evolved in one way, while the animals on the future continent of Australia evolved in a completely different direction. This is why Australia became the kingdom of marsupials, mammals that carry their young in pouches like kangaroos and koalas. Over millions of years, the Australian plate drifted northwards, slowly closing the gap with the Eurasian plate. As it moved closer, islands began to form in the sea between them. Some of these islands were fragments of the Asian plate, while others were pieces of the Australian plate. This created the complex archipelago we see today. However, the deep-sea trench that marks the Wallace Line never closed. Even during the ice ages, when a huge amount of the world's water was locked up in glaciers and sea levels dropped by over 100 meters, this channel remained a formidable water barrier. The western islands became connected to mainland Asia, but the eastern islands remained isolated. This long history of separation is what makes the area known as Wallacea, the group of islands sandwiched between the Wallace Line and Australia, so unique. It's a transition zone where you can find a strange mix of both Asian and Australian species, as well as many creatures found nowhere else on Earth. The Weber Line is another boundary within Wallacea that marks the point where Asian and Australian fauna are found in roughly equal numbers. It's a zone of overlap, a biological melting pot. This makes Wallacea one of the most biodiverse and evolutionarily important places on the planet, home to unique animals like the babirusa, a pig with upward curving tusks. A similar, large-scale event happened in the Americas, known as the Great American Interchange. For millions of years, North and South America were separate continents, and South America, like Australia, had a very unique collection of mammals, including giant ground sloths and fearsome terror birds. About 3 million years ago, the Isthmus of Panama rose from the sea, connecting the two continents. This created a land bridge, allowing animals to migrate in both directions. Animals from the north, like bears, big cats, and deer, moved south and outcompeted many of the native South American species. At the same time, animals like opossums, armadillos, and porcupines successfully moved north, and their descendants are still there today. Invisible lines aren't just found in nature. We create them on our maps too, sometimes with strange results. There's a cartographic curiosity called the Baltimore phenomenon. This happens when a smaller, independent city is located near a much larger one. On a large-scale map of a country, mapmakers might only have space to label the major city, but as you zoom in on a regional map, the smaller city suddenly appears, seemingly out of nowhere. It's not that the city wasn't there before, it was just omitted for clarity. It's a good reminder that maps are simplified representations of reality, and what gets included often depends on the scale and purpose of the map. Speaking of strange lines on maps, Australia has some of the most unusual time zones in the world. Most countries set their time zones in neat, 1-hour increments, but Australia throws that rulebook out the window. While the East Coast follows one time and the West Coast follows another, South Australia and the Northern Territory are offset by just 30 minutes. To make things even more wonderfully weird, there's a tiny, unofficial Central Western time zone used by a few small towns along the air highway. It's 45 minutes ahead of Western Australia and 45 minutes behind South Australia. It's a quirky solution for a remote part of a vast continent. This vastness leads to some truly unique places, like Alice Springs. Located almost perfectly in the geographic centre of Australia, it's one of the most remote towns on Earth. It is roughly 1,500 kilometres away from the nearest major city in any direction. Living there means being truly isolated, surrounded by the harsh, beautiful expanse of the outback. Much like the animals separated by the Wallace Line, the people and culture of places like Alice Springs have developed a unique character, shaped by their isolation and their environment. It just goes to show that whether they are created by deep oceans or vast deserts, barriers shape life in the most fascinating ways. From the deep water trench of the Wallace Line to the quirky time zones of the Australian outback, our planet is full of fascinating borders, both visible and invisible. These lines tell incredible stories of deep time, continental drift, and the grand journey of life on Earth. They show us how isolation and connection have shaped the world we see today, creating the stunning diversity of animals, plants, and even human cultures across the globe. The next time you see a map, remember the hidden stories it might be telling of ancient oceans, migrating animals, and the invisible lines that divide and define our world.